Hi, so welcome to this session on Bitcoin and other cryptocurrencies. As we said, we'll initially deliver the session. Once the session is over, then I will request all of you to have your questions ready. You can type your questions in the question pane and we'll discuss them at a later point of time after my delivery of the Bitcoins and cryptocurrencies is done. Now, before we begin, let me introduce our company. Our company is a company which is in consulting and in trainings. We basically focus on banking and financial services. We have got basic three divisions. We do trainings and consulting in banking, financial services and investment banking. We also have a division which does IT security, implementation of ISO 27001. We also have a team which does the vulnerability analysis and penetration testing, the VAPT. So IT security is the second division. The third division is focused on the risk management and risk advisory services. Now, having given the brief about our company, I'm Makaran. I'll be with you throughout the session. Let's begin the discussion now on Bitcoins and cryptocurrencies. Let me first introduce the content. What I'm going to discuss today is what is Bitcoin. Of course, we'll be covering cryptocurrencies in fact. Then the concept of Bitcoin and the process of how it operates. And then we'll conclude the session by going next to the advantages and disadvantages of this process. Once we complete the advantages and disadvantages, as we just said, we will take then the questions and answers. Now, before we begin, a notice, a warning that this session is only for providing information about cryptocurrencies and their usage. Now, we at MVLco do not recommend or neither recommend usage of cryptocurrencies nor are involved in dealing with any cryptocurrencies. Any person using this information provided in this webinar can use it at their own cost and risks. This webinar presentation is made only for academic purposes. We do not have and do not accept any liability or responsibility in respect of usage of information provided in this webinar. So this is the basic safe harbor statement which we have. Now let us start with the discussion on the cryptocurrencies. I am starting with our first slide. This is basically about a big transaction which took place in 2010. Now you see a couple of pizzas on the screen. Now in 2010, a Florida programmer and a Bitcoin talk user, Laszlo, offered to pay 10,000 Bitcoins for this pizza. Now this transaction is famously known throughout the crypto community now as the first real world transaction of purchase by using a Bitcoin. This day, that is May 22nd, 2010, is also known as the Bitcoin pizza dinner. So this is the largest transaction which happened 10 years ago. Now the gentleman Laszlo posted on Bitcoin Talk that he would like to give 10,000 Bitcoins to anyone who bought that pizza, bought a pizza for him. Now someone in UK took this order from him, ordered 2 pizzas from Papa John's and delivered them to Laszlo. Now when he delivered them to Laszlo, that person who bought the pizzas from Papa John's paid only $25 and he got in turn 10,000 Bitcoins. Now when he got those 10,000 Bitcoins, this is the chat which Laszlo had put up on his website about having ordered the pizzas first, and then after that he just reported that he successfully paid 10,000 Bitcoins and got 2 pairs of pizzas, 1 pair of a pizza. Now when you look at this, the current value just within 7 years time or almost 8 years time, this was done on May 22nd, 2010, the current value of 10,000 Bitcoins at yesterday's price of US dollars 14,100 per Bitcoin, this amount of 2 pizzas would be $141 million. Now fortunately or unfortunately, if Laszlo had kept this money, 10,000 Bitcoins with him, he or his future generations would never need to work. Now today, many persons are using Bitcoins as currency or money. However, some of the countries are treating this Bitcoin as a commodity. Now what is this virtual currency? What is this digital currency? Now a central bank in Europe defines the virtual currency as a virtual currency is a type of unregulated digital money which is issued and usually controlled by its developers, and it's used and accepted among the members of that particular virtual community. As per a survey conducted recently, The current number of active users of cryptocurrency wallets is estimated to be between 5.8 million and 11.8 million. These are estimated to be the active wallets across the world. Bitcoin started operating in 2009 and it is the first decentralized cryptocurrency. The second cryptocurrency called Namecoin did not emerge in fact till 2 years later in April 2011. Now today there are hundreds of such currencies. We will be discussing about them in a while from now. So when we have these currency schemes, the currency schemes are used for making the payment. Let's now go to the history first before we understand how this operates. The way I am designing this session is first introduce the background of cryptocurrencies. Once we understand the background of cryptocurrencies, then I'll explain to you the concepts involved in that, like the blockchain, like the hashes to be calculated, then the concept of mining. Once you understand those basic concepts, then I will take you forward to the concept of how the process actually works. Once we understand how the process actually works, then we will move to the next part, which is what are the benefits and what are the disadvantages of using a Bitcoin or any cryptocurrency. That's how we are going to take this session today. Now let's move forward to the next slide and look at a bit of the history. Now when we speak about Bitcoins, the Bitcoins started somewhere in January 2009, but cryptocurrencies or digital currencies have been there since 1990s. The first cryptocurrency or digital currency dates back to 1990. It was called e-gold. Now that was the time of the dot-com bubble. This e-gold was founded in 1996 and was backed actually by a real gold. That means you would need to get gold to get the cryptocurrency called e-gold. This e-gold was a digital currency operated by a company called Gold and Silver under the e-gold limited concept. It allowed users to open an account on their website. Now this account was denominated mainly in grams of gold, and the users were allowed to make instant transfers of money by using this e-gold account. So one e-gold account customer could transfer the money to another e-gold account customers, and this e-gold account was backed by real gold at that point of time. The system was launched in 1996 and had almost 5 million accounts by 2009, when the transfers actually were suspended by the US government. The US government suspended this transfer because they were suspecting that this e-gold system was being used for laundering of the money. At its peak in 2006, e-gold was these accounts were processing more than $2 billion US every year, and the basic quantity of gold which was backing this currency was only $71 million. So with $71 million, the transactions processed were of $2 billion. Now the second currency which was there, which was very popular, founded in 2006, was the Liberty Reserve. It was allowing the users to convert US dollars or euros to Liberty Reserves or Liberty Reserve dollars or Liberty Reserve euros. And then by charging the users 1% fee, the users could pay each other in either Liberty Reserve dollars or in Liberty Reserve euros. This was a Costa Rica based centralized digital currency service which was calling itself as the oldest, safest and the most popular payment processor. So this is the second one. Now remember, in both these cases, e-gold and Liberty Reserve, we had a centralized system. In e-gold, we would have e-gold company receiving the messages from the party who would like to make the payment and then passing on that entry or passing on that money to the other side. Same was the scenario with Liberty Reserve. Liberty Reserve was also a centralized digital currency, not a decentralized digital currency. Now what is centralized? What is decentralized? I'll be covering in the subsequent part. Another one which is very, very popular, mainly on the Chinese side, are Q coins. Now these were used as a commodity based digital currency. This is introduced by a company called Tencent QQ. It's a virtual currency used by QQ users, and using this currency they can buy various items by going to that particular website. So they can use this currency as if it's real currency. Now to summarize then, what I want to tell you is that digital currencies are not something which is new, but the digital currencies which you see on the screen, like the e-gold, like the Liberty Reserve or like the Qcoin, are centralized digital currency. E-gold would be operated by the e-gold company, Liberty Reserve again operated by a particular company, and even Qcoins operated by the Tencent company. So in this case, all the messages would get routed through the company. So let's understand what is the concept of this centralized system. I have been speaking about centralized system and telling you that we use centralized system in e-gold, Liberty Reserve. In fact, when we make any of the payments today by using the traditional payment systems, we are using a centralized mechanism. Now, many of you may be using internet banking or mobile banking, but then using this internet banking or a mobile banking, you are connecting to your bank, and if you want to make a payment to somebody else, and if that somebody else is with some other bank, then in that case, connecting your bank with that other bank, there is some kind of a clearing system, which is a centralized clearing system. For example, in UK, you can use faster payment. In Australia, you can use the new payment platform. In India, you can use the IMPS. So all these systems like IMPS is operated through the National Payments Corporation of India. So when I, in India, want to make a payment to you in India, I would route my transaction ultimately to the centralized agency called National Payments Corporation of India, and from NPCI the transaction gets routed to your bank on the other side. So here in IMPS in India, we are using the centralized service. Then when you look at the other private players like a PayPal or the M-Pesa in Kenya or MobiKwik in India or Paytm in India, again you connect to these central agencies like a Paytm or like the PayPal, and when I want to make a payment to you using PayPal, I pay PayPal and PayPal passes on that message onwards to you. That's how we have these as these centralized systems. So these centralized systems have certain kinds of disadvantages. So let's understand what are those certain kind of disadvantages. Now we also have other important systems which have been released globally. I'm sure you have heard of Google Wallet, which was released in 2011. Again, when you want to make a payment, you need to touch base with Google, or Apple Pay can be used to make the payment. Apple Pay was released somewhere in 2014. So most of these important large value payment systems, you could think of some large value payment system like CHIPS in USA or Fedwire in USA or Target 2 in the single euro payment area, or you can think of the RTGS system in India or the RITS in Australia. All these large value payment systems are centralized payment systems. And like we just discussed, the small value instant payment systems like IMPS or NPP are also centralized payment systems. And as I was saying, the centralized payment systems have certain issues. Now, well, when the things are centralized, everything must go through that single entity. So as I said, if I want to make a payment using a system like a check-based payment system, then I give a check to you. I bank with bank A, you bank with bank B. When you deposit the check in bank B would send that to a centralized clearinghouse, and through that centralized clearinghouse, the check would come to my bank. So we need this centralized system. Now when the centralized system is to be used, there are issues involved in the centralized system. Now when the processing of messages happens, because every payment happens with a message, the message could be a check, message could be a mobile message, the message could be a card swipe on a POS machine. So when you create a message, whether we are going to send this message to a central system or in a distributed system is the distinction which we are going to discuss now. So when I use the traditional mechanism, we have a centralized mechanism. For instance, you swipe your card on a POS machine, then the message leaves the POS machine and reaches the acquiring bank. And from the acquiring bank, it will go to somebody like a MasterCard or Visa, and from MasterCard or Visa to your actual issuing bank. So again here, we have got a centralized system operated by Master or Visa. Now the issue with the system is then the information of such messages moving is available only with the centralized system. And since the system has to process all transactions, for example, Visa processing millions of transactions, or maybe somebody like an NPCI processing millions of transactions, the transactions come to one junction, one hub, and then the hub gets too many messages, and then the systems can become slow. So if you want to access information also from these systems, it takes a little time. Processing of the transactions can take a little time. So one disadvantage of the centralized system is these centralized systems can be slow. Second point, when you want to get information now from the centralized system, you need to be identified. Somebody will say, I need to verify your identity, then only I will provide you the information. Third and the most important thing, since we are operating in the centralized manner, creating such a huge infrastructure to manage payments is an expensive affair and difficult to maintain also. So there is an expense involved in creating centralized system, and there is expense involved in regularly managing and updating the system. So when you need a centralized system, when you use centralized system, they are going to be very, very expensive to maintain, expensive to get created. Other point about the centralized system is that since the centralized system have a centralized database, if somebody hacks into that centralized database, or if that centralized database gets corrupted, in that case the entire system can come to a standstill. And if the central system comes to a standstill, then the entire payment processing can stop. These are the issues associated with the centralized system. Now all these issues can get addressed when we are using the decentralized system. So let us understand what we mean by using a decentralized system. Now in a decentralized system, we'll have something like a blockchain. Now what is a blockchain? How it performs? I will explain that to you in a while from now. Let's understand how many kinds of such decentralized chains are there, decentralized systems are there. Let's look at a website. I'll be taking you to various websites during this session so that you are able to understand how the process works. So let's go to one website and see how many cryptocurrencies exist. Now on the screen, which you will be able to see now, you will have multiple cryptocurrencies, starting with the biggest one, which is the big Bitcoin, which is the most popular across the world. Now Bitcoin's price today is $14,263 per Bitcoin. The circulation is these numbers. Then you have the volume of transactions in last 24 hours. This is what you see. The next popular one is Ethereum. Then you have Ripple, Bitcoin Cash, Cardano, and many more like this. So how many more would be like this? There could be almost around 1300 plus. In fact, now we have got 1426 such cryptocurrencies available across the world. So when we have these cryptocurrencies, the transactions have to be done across the world in a simplified manner. So I will now explain to you how the process is done. To summarize then, we will have various cryptocurrencies. There are many players in the cryptocurrency area. So when we have this many players in cryptocurrency areas, there are differences in the manner in which these cryptocurrencies operate. Some of them are good, some of them are not so updated. So there are differences in the quality of service which each of them provide. Let's understand what we mean by the concepts of cryptocurrency now. Now when we are speaking about the concept of cryptocurrency, the basic thought of Bitcoin was introduced by a gentleman, a person called Satoshi Nakamoto. In November 2008, Satoshi Nakamoto published a paper which was called a peer-to-peer electronic cash system. Now this peer-to-peer electronic cash system is what I am calling as decentralized system, because we will have a network of a large number of people connected to each other by using the electronic system. So imagine that we have got millions of people across the world who connect to a common pool, who create a common network, a common pool. That is what we are speaking about when we speak about a decentralized network like this. Let's have a brief look at the paper created by Satoshi Nakamoto. This is the Bitcoin, a peer-to-peer electronic cash system paper released by him in 2008. Now this system, this paper speaks about the transactions and how do we create the transactions. Let me now explain the manner or background in which the transactions are getting created. And at this time, I will also use the check payment system as the another payment system, which I am using this because basically all of us have used check payment systems in the past. And in a check payment system, as I said a little while ago, when I give a check to you, you deposit the check in your bank. That check instrument moves from your bank to the clearinghouse, from the clearinghouse, which is a centralized place, to my bank, and my bank would make the payment. This is the basic process of how a centralized system would operate. Now as against that, what Satoshi proposed was, instead of sending this check, I'm using the check only as an example, instead of sending this check to a centralized clearinghouse, let's send the same check to everybody and let everybody verify and have a look at that check, and let everybody verify the signature on that check. And if 51% or more confirm that the signature on the check is genuine, then we accept that transaction. This is how I am putting the logic in front of you by using the analogy of the check-based payment system. what Satoshi said, that we will define an electronic coin as a chain of digital signatures. So what moves forward from one person to other person when you pay somebody else by using a cryptocurrency, actually what you are forwarding is a chain of digital signatures. Each owner transfers the coin meaning that kind of a transaction which carries the digital signatures. Each owner transfers the coin to the next by digitally signing a hash of the previous transaction and the public key of the next owner and adding these to the end of the coin. A payee can then verify the signature to verify the key, verify the chain of ownership. Now here what is involved is using the PKI, the private and public key infrastructure. So what I would do, if you look at the screen, you have got the transaction. In the transaction you have got owner first public key. Owner 1 would also have his private key. What owner 1 would do is create a message saying owner 1 wants to pay owner 2. This message is created. Owner 1 would sign that message by using his private key, and when he signs that message using his private key, along with the message, he is going to forward his own public key to the next party in the chain. When next party in the chain receives this transaction, what it is going to get is this message that you are getting paid, and along with that person is going to get the public key of the owner 1. That means the sender's public key is what will come to the second party. When second party receives this message, it will decrypt this message by using the owner 1's public key. If it gets decrypted properly, then we know that this message came from the owner itself. So I have explained one part of the process. Let me repeat this process. I said owner 1 will sign the message with his own private key, send it forward along with his public key to the recipient, the owner 2. Owner 2 decrypts it by using his public key. But then this only tells us that owner 1 signed that message, created that message. How do we ensure further integrity of the message? To do this, owner 1 needs owner 2's public key. So I'll repeat the transaction in a different way now. Owner 1 has his own public key and the owner 2's public key. Both are there. Both these are there with owner 1. How does owner 1 get owner 2's public key? Is because owner 2 has published his address, and along with his address, his public key is distributed to everyone in the network. So with this, everyone's public key, that address's public key would be available with me in case I want to send a message to that particular address. So to repeat, owner 1 creates a message. He uses owner 2's public key to encrypt that. He also uses owner 1's, that is his own private key, to encrypt that and forwards that message along with his own public key to owner 2. When owner 2 gets his public key, owner 2 uses his own private key first to decrypt the message, and he also uses owner 1's public key to decrypt the message, and then he knows that the transaction came from owner 1, and he also knows that the transaction has not been modified. In this way, using the PKI, in fact in traditional payment systems also, like your payment systems where card payments are involved or internet banking is involved or RTGS payments are involved, we do use such public and private key infrastructure. All our traditional centralized systems also use this mechanism. The same mechanism is available here, but implemented in a little different way. Now when the transactions are published, created, they are publicly announced. This is very different than the traditional payment system. When I give a check to you, you only deposit it in your bank. You don't publish it to everyone that this is the check I have received from Makaran. And then what we are going to do here, we will use the others to verify the messages. So part 1 is you create messages, sign them, and what gets forwarded from one party to the other party are the signed messages. Now at this time, we will also have this concept of proof of work. I'm going to deal with this proof of work in detail at a later point, probably on slide number 9. The proof of work involves scanning for a value. That value, when hashed, like a hash mechanism which I'm going to show to you is SHA-256, the hash begins with a number of 0 bits. For our timestamp network then, we'll implement the proof of work concept by incrementing a nonce in the system. Now what's a nonce? Nonce is a number, and that number can be used again and again. So you're going to use that nonce. Sorry, a nonce is an arbitrary number that cannot be used again and again. It can be used only once. It is actually the number which is a randomly generated number, and it could get added, and once it is added, we are not going to use that arbitrary number again. That's how the nonce would get generated. So what's the concept of nonce? How do you generate the hash? You'll need to hold it till I go forward. I'm just explaining you the concept. Then what he said, I'll repeat what we have said till now. We create a message, we sign it with our own private key, we also add our own public key to that, and we also use the recipient's public key to encrypt that, and then we forward it to the network. Now what does the network do? The network will receive all such transactions. They will collect the transactions and put them in a block. A block may contain multiple number of transactions then. Each node will then start working and trying to find out a difficult proof of work for its block. When the node finds a proof of work, it broadcasts the block to all the nodes. To give this, I'll use another analogy, a very simple one. Now many of you would have played a game, a card game called Rummy. And in Rummy, what you need to do is the person who gets the sequence created first is the winner. In the similar way, in this system, we'll have a person who will want to solve that algorithm, solve that problem, and the one who solves the problem first has the opportunity to add the block to the next chain. In this way, you create the proof of work, and once that is done, then the block will get created. Nodes will accept the block only when the transaction in it are valid and not already spent. So this is what is the concept of double spending. You cannot spend the money again and again. That's what is to be done. For example, in a check, when I give a check to you, the check is paid, that check cannot be reused. That's the concept which is here, that you cannot double spend, you cannot use the payment again. Here it would become possible because in a check you destroy the check, or maybe you invalidate the check, but this is an electronic one, so it may be possible for me to create a copy and then use the copy once again. So we need to have a system in place to prevent that copy from getting reused. That is called double spending. So nodes will express their acceptance of the block by working and creating the next block in the chains, and that's how the blockchain would get created. We'll discuss blockchain once again after a little while. The nodes will consider the longest chain to be correct and will keep working on and extending that chain. So now it's going to be like a train. You'll have an engine, and more number of bogies, more and more number of compartments will get attached to it, and it will become longer and longer. If the nodes broadcast two different versions of the next block simultaneously, some nodes may receive one or the other first. For example, I am trying to send one block number A. Somebody also tries to attach block number B simultaneously. Then which block would be getting attached first? The block which will get attached first is the one which is received by the others. And then if two simultaneous or parallel chains get created, then in that situation the longer chain will continue, the smaller chain will be broken away. This is how the concept came. And then with this, why should people do all this exercise? They need to get some incentive, and that incentive comes when you solve the problem. When you create a block and your block is accepted, then you get some kind of reward, and by convention your reward is paid to you is by creating the first transaction in the block. The first transaction in the block is a special transaction that will start a new coin owned by the creator of the block. So if I create a block, you create a block, and your block is accepted, then you get a Bitcoin as a reward. So our incentive, our reward for continuing this process is the Bitcoin which gets generated. This is where we will touch the base on mining at a later point in time. So this is the basic structure, bit of history, basic structure. I will go into the detailed structure in a while. Let's move forward from here. Nakamoto then implemented the Bitcoin software as an open source code, released that in 2009. The identity of this person, Satoshi Nakamoto, still is unknown, though many people claim that they know who this person is. Now once he created this concept in 2008, in January 2009, the Bitcoin network came in existence after Satoshi Nakamoto mined the first block on the chain. This first block is known as the Genesis block, and it had a reward of 50 Bitcoins, which you can see at the bottom of the screen. Generation 50 blocks. So the one who solves this will get 50 Bitcoins. Another concept you need to keep in mind at this point is the difficulty level. I'm going to use the concept of difficulty level at a later point of time. So now when we have understood this concept of the history, let's now go to the major concepts in Bitcoin. Now when we speak about major concepts in Bitcoin, the first major concept to be understood is the distributed ledger technology. A distributed ledger, some people may call it as a shared ledger or also distributed ledger technology, is a chain which you can see on the right hand side of the screen. It's a consists of replicated, shared, synchronized digital data spread across the world. So it's not that it's there only in one place. It is all different computers. Imagine those small blocks which you see, small pieces which you see on the screen are all different computers across the globe. And what we have done is created a network of computers across the globe. This is what we call as the distributed ledger. Now each of these computers, each of these nodes, as I will call them, each of these nodes will process the cryptocurrency transactions. Each of the nodes will then mine these transactions if required and store the data about these transactions. So point one is we will start with a distributed ledger. In the traditional system, like the check-based system I was speaking about, the clearinghouse will maintain a centralized ledger. So clearinghouse will compute the obligation, what one bank has to pay to the other bank. So in your RTGS systems or the automated clearinghouses, it is the clearinghouse which maintains the centralized ledger, tracks the movement of money from one party to the other party. The same thing happens in case of your settlement systems in securities, that the stock exchange as a central clearinghouse will track the movement of securities, bonds, equity shares from one party to the other party. In this situation of distributed ledger, we will not have such a centralized clearinghouse. We'll have everybody playing a role of clearinghouse part by part. This first is this step of distributed ledger. A distributed ledger then eliminates the need for central authority to verify asset ownership. It actually holds all the information and then cuts down the process, increases the speed. This is the first concept of distributed ledger. Everybody who has a wallet, has the agent, will have the distributed component on their machines. Now the second part is the hash. I used the word digital signatures earlier. So I would have the digital signatures of both the sides, the sender of the message, the receiver of the message, and of course of the earlier message also. Point two, when the messages are to be transferred, we need to verify the signatures. So we need to carry them forward in such a way that they are secure. Now to do that, we need to create hash function or use the hash function. What is hash function? Hash function are small computer programs that transform any kind of data into a number of fixed length regardless of what is the size of the input. Let us have a look at how this hash gets created. I am taking you to a site to understand this concept of hash. Now this is the hash generator which you see. I have a SHA-256 online hash generator. Now the hash functions only accept one piece of data at any given point of time and create a hash value based on the bits and bytes that make up the data. So I am going to type here, welcome to the session. When I type here welcome to the session, it is going to generate a hash of that message which you can see at the bottom of this message. This is the hash of the message where I said welcome to the session. Now when you have a hash function like this, an important group of hash functions known as cryptographic hash functions are used in the process of cryptocurrencies. Now when we have these hash functions used, the hash functions used in Bitcoin is called SHA-256, SHA-256. SHA stands for Secure Hash Algorithm 2 or 256. This is a set of cryptographic hash functions designed by the National Security Agency in United States. Now given a hash of a piece of data, now what that piece of data is going to be? In our example, the piece of data is going to be the transaction information. And of course, you could carry the signatures of both the parties. It is possible then to later confirm that the data was not tampered with by rehashing the data. So you reverse engineer and then find out whether the data was tampered with and whether the data came from the right party. Now Bitcoin does not use any concept of encryption. All transaction information is available publicly. I'm going to show that to you in a while from now. It also uses a digital signature scheme called elliptic curve digital signature algorithm. Now the mathematics for this algorithm is very complex. It's more complex than the most of the time which RSA public key crypto systems which you use, but this is considered to be more secure. Now let's understand one more point. At the bottom what you see of the screen is known as the Merkle tree, where you can see numbers 0, 1, 2, 3, 4, 5, 6, 7. Now what is the purpose or the use of having this Merkle tree is also what I need to explain to you. So when we get these transactions, let's go back to the example of a check and then correlate it with this concept. Now if I give you a check to you, imagine that you're not going to give it to the clearinghouse, you're going to send this check across to different parties, the same check. And when I buy a check to, let's say, a person called Nishamani would hand this check onwards again to another person called Rahul. Rahul hands this person a check again to another person. So instead of passing the same check, what we will do, I give one check to Nishamani. Based on this one check I give to Nishamani, she writes one more check, and both these checks, my check given to her and her own check created by her, is passed on to the next beneficiary called Rahul. When Rahul gets the checks, he will have two checks, one given by me, Makaran, second created by Nishamani, and when Rahul wants to pay, Rahul writes his own third check, gives it to another person called John. So when John gets the checks, John will get a check first created by Makaran, then created by Nishamani, then created by Rahul, and John has three checks in his hand. Now when John wants to make a payment to the next person will receive one more check from John, and then if you continue with this mechanism, large number of paper checks will have to be carried out in the entire chain. Now apply this analogy. If I carry the complete data of all the historical checks, historical transactions in the next transactions, the size of the transaction is going to become huge. So the concept of Merkle tree is to reduce that size of transactions, and that's what you see on the screen by way of that 0, 1, 2, 3, 4, 5, 6, 7. Now at the bottom of the screen, in that block, in that picture, you have 0, 1, 2, 3, 4, 5, 6, 7. Now imagine 0 is the first check created by me. If I give the check to Nishamani, Nishamani creates check number 1, and when she gives it to the next person, Rahul gets check number 0, check number 1, and he writes his own check number 2. And like that, if the checks go on moving, the 8th person will have all the checks from serial number 0 to serial number 7. We want to solve this problem, and this problem is solved by using the concept of Merkle tree. So in Merkle tree concept, instead of forwarding the complete data of all the historical transactions, what we are going to do is carry the hash only of, or the summarized process, the way I will use the check concept again, a summary of all those checks to the next party rather than carry the entire process of checks. This concept was introduced by Ralph Merkle in 1979. This is called the idea of the hash tree, now known as the Merkle tree. So in this situation, what we do, we carry forward not the entire data but a hash list. To apply it to my example, hash list would then indicate the kind of checks which have been issued in the past which support the next check. Why do we need to carry the checks is another concept we need to understand. In a decentralized system, there is no centralized book. So how would the next person know that I have got adequate money to spend? For example, when Nishamani receives the first check from me, how would she know that Makaran has got adequate money to pay? This is proved by my providing her with the proof that I received the money first from somebody else. So Nishamani receives, let us say, 10 bitcoins from me through message number 1, which you see on the screen. In that case, when Nishamani out of these 10 bitcoins wants to pay somebody else, needs to prove to the next person that she received it earlier from somebody else, and therefore the historical data has to be carried in that transaction chain, because we do not keep that data about what is the balance available with everybody in a centralized ledger. The transactions themselves will carry the information about what is the amount which the payer received. So if I want to pay, the transaction created by me will carry this information of this information about from where did I receive my money. If I can prove that I received bitcoins, then only I am allowed to pay those bitcoins. So to prove that, I need to provide the trail of the historical transactions. With that concept, we need to have the Merkle tree. And if I keep on providing complete data of all the historical transactions right from the Genesis block, the transaction volume, the size of the transaction will become big. And to reduce that process, we use the concept of the Merkle tree. So this is the second concept. We have discussed two concepts till now: distributed ledger technology and the hash creation and the Merkle tree. The third one is mining and proof of concept. So let's understand this proof of concept and mining. Now how do we mine? To mine, we need to use an application. I'm going to show you an application. There are various applications available on the web. Let me see whether this application opens on my screen. It does, but it's in a smaller way. I don't know whether any of you are able to see this application. This application is called GUI Miner, and it allows me to create a miner. I have joined a pool called Slushes pool. What's a pool and why it is required? I'll explain that to you in a while from now. I've created a worker called demo worker, and this demo worker can be told to start mining. This is the miner. Then my miner's name here is default. Currently he is not doing any mining, and since he is not doing any mining, no transactions are accepted by the pool and nothing has become stale. Let me start doing that mining. So now I push this button called mining. It's now connecting. It's saying connection problems, but it will connect in a while from now. So what this tool will do, it will pick up those blocks and do the mining process. Now here you can see it's doing mining. It's doing mining at 28.1 mega hashes, 27.1. This speed will keep on going up and down. So to do mining, you need to use a miner or a mining application, which is what you see. There are, as I said, number of such mining applications are available. You could pick up any one of those mining applications and start doing the mining. Now what is mining? As I said, I'll be covering in a while from now. And you also need to provide a proof of work. Now what is this proof of work? As we used the word knowns earlier. Now when we want to do mining, we need to search for acceptable blocks using the procedure which has to be performed in a loop. We increment, add 1 to an arbitrary number, which number we called earlier as the knowns. Create the hash of the resulting block. So I'll repeat what I said. We pick up a transaction, we add an arbitrary number in the block header, that is called the knowns, then create the hash. I showed you how to create the hash by taking you to a website. Then check the hash and find out whether the hash created is below a certain target value. Now that target value, who gives it? The target value is again given by the system itself. So when I create the hash of that block header has to be less than the target value. What happens if it is more than the target value? If the hash is more than the target value, the block will be rejected by the network. So finding the block that has the sufficiently small hash value is basically solving or giving the proof of work. Now let's look at how these blocks look like and how they create. I'm taking you to a system. In this system, on this slide, you'll be able to see number of blocks, latest blocks, and it gives you the block number, how old is that block, how many transactions are created or into that block. So let me tell you one more thing. A block will have more than one transactions. It's not limited. One transaction, one block, that's not the way it gets created. In this particular block which you see, we have got 8574.07 bitcoins transacted. This block was ultimately mined by Slush Pool. The size of the block is 1050.5 KB and the weight, the size is 3.992.87. You could dive deeper into this block because we said this is public information. So let me dive deeper into this block and tell you what is included in this block. Now this is the block. These are the details of that particular block. We have number of transactions. We have got the output total, the estimated transaction volume, transaction fees, then height, that is main chain, timestamp, then who relayed it, the difficulty level. Remember the concept of difficulty we spoke about a little while ago, that if you recall the Genesis block, the Genesis block had difficulty level 1. And now look where is the difficulty level reached. This is the difficulty level now. And since this is a very high level of difficulty, it's quite difficult, quite impossible for a single party to go on processing this transaction. Then you get the bits there and then you get the reward. As I said, why should somebody do the mining is because they get the reward. So this is the reward which the miner is getting, and these are the individual transactions. So these are 1665 transactions in a block number called 503983. In that block, all these 5000 or whatever is those 1665 transactions, all these are listed here. You could again go inside those individual transactions and identify what is being done. Only thing here, however, we will not be able to identify the persons because these blocks will carry only the names, the addresses, and addresses do not divulge the person. That's how you get the block created and block mined. I'm still on the basics. I have not gone further. So we have understood the concept of how do you do mining by using an application. Then you release this block into the system and then if it gets accepted, you get a reward. That is the concept which I have explained till this point. Now let's go to the concept of mining pool. Now why do we need mining pool? One point which you noticed was the extent of difficulty. Now it's quite difficult for one person now to go on mining and successfully mine a transaction. So in order to have effectiveness, efficiency, and with the increased level of difficulty, it is going to become difficult for people to go on mining on their own. So therefore you need various parties joining their networks and coming together in a pool. This is the same example which I was showing to you a little while ago. This is what is happening in last 24 hours. So you could see the percentages, and you can see the pool called btc.com is the biggest mining pool. The next biggest pool is the Ant pool. 19.7% of the transactions have been mined by them. And in this way, people would join the pools. The pool itself will charge some fees to the parties for allowing them to join the piece. So suppose the reward is received, a part of the reward will be kept by the pool and the remaining reward is shared between the parties. So by joining a pool, those who would like to do the mining would be having the earnings. This is the concept of the mining pool. Now once the mining starts and the proof of work is done, the targets have to be achieved. As we said a little while ago, the target is to get a number, a hash, which is less than the target value. And we said that the target value is decided by the system. Bitcoin generalizes this target value by allowing targets to be numbers. So what is a target? It's a number that starts with zeros and followed by a specified pattern of binary digits. All of them need not be zeros. And then the nodes calculate a new difficulty level after every 2016 blocks, 2016 blocks. A hash value is then the number of 256 bits, so that you could get this target value and try to do the transaction or get the hash below that target value. If you do that, your block can get successful. I'll go back to the example which I used. Now this is how you will get your sequence in the card game called Rummy. So we create the blocks. Now then we go to the next concept, and one of the most important concept of a blockchain. Now blockchain is a continuously growing list of records. You can see that at the bottom of screen here. The gray block here, what you see is the original Genesis block. The black blocks which you see here are those blocks which are accepted. The blocks which are in a different color, that is they are in bluish color, those are there, but those are not considered. Those cannot get considered because we said when we are reading Satoshi's paper, we said that only those blocks which are in the longest chain will get accepted. So those blocks on the screen which you see in blue are not likely to get accepted. They will be removed ultimately from the chain and will be put back again put back in the pool for mining. So the leftmost block is what we call as Genesis block, and the other blocks is what will get added. This is how the blockchain gets created. Now when we have the blockchain getting created, let's have another visit to a website to see the blocks. Now you again see those blocks, but one more thing which you'll see here now, all these are the transactions, latest transactions which are coming into the system. Now what you are supposed to do is pick up these transactions and then use these transactions for carrying out your transactions processing. This is the concept of the transaction. Using or picking up the transactions, you need to create a block. So now let's start understanding the process. I have explained to you the basic concepts involved. Now another point, when you are doing this, could it be quite expensive to do it? So how do you calculate whether you're going to make money or whether you're going to lose money? So you also get the calculators telling you that if you're doing the process at a particular speed, how much will you make? Now in my machine, the application which I was showing to you, the GUI miner, I am doing the mining. My speed is 25.9 maximum. It's now 27 mega hashes. So if I keep on mining at that speed, would I make profits? So I'll just put 25 here. If I put 25 here, obviously I'll be losing money. So my speed is not adequate, which means to make profits, I need to mine at a speed which will give me profit. So let me add another couple of zeros there. If I mine at this speed particularly, then I would start making profit. So my normal laptop would not provide me with adequate computing power to go on doing the mining. You must have specialized equipment nowadays. You get the application specific integrated circuits today, which provide you specific systems, specific PCs or laptops which will carry out the mining. Now, having understood the basic concepts, let me take you to the most important portion of how would we now process the transactions. Now let's understand that by using an application, I will create a transaction. Let's see that process of how do I create. This is a wallet. Now you can download any wallet from any place, and once you download the wallet, you'll be able to create a transaction. In this wallet, I do not have any Bitcoin, so I'll not be able to pay, but I pick up a address. My wallet would have an address. I could have multiple addresses for my wallet. So I pick up a wallet. So in order to use a Bitcoin, I need to download the free and open source software called a wallet. And if I get a Bitcoin, these are stored on my wallet. This could be stored on my computer. I could store it on a separate hard disk. I could take a paper print of that and use that. If I keep it on the hard disk, let me tell you a problem also. If I keep my wallet on my laptop or an external hard disk, then if that hard disk gets lost, then I could lose money. In fact, I'm going to share an instance like that with you at a later point. The transactions are anonymous, which means I will be identified only by the address, and the party whom I will be paying will also be identified by its address. The transactions are anonymous, the accounts are not registered, and now I will use this wallet to send the money to somebody else. Now I could also create the QR code, quick response code. So when I say pay Jack Welch, this is the QR code. If I change the wording, you can see the QR code changing. Pay Jack Welch today. If I add that, so I could have changes again happening here in the QR code. Now what I will do, I will initiate a payment using such a wallet. Let me go back to the transaction again, the scheme again. I will create a Bitcoin. I'm on step 1 here. I'm creating a Bitcoin by using this kind of a wallet. So I can generate multiple Bitcoin addresses also. So I could have one wallet having multiple addresses. All of them can belong to me. Now when I initiate a payment, my wallet will create a transaction message and it will submit it to this peer-to-peer network, which you see as the blackish colored circle. So it submits that to the peer-to-peer network. Basically, my transaction created by the wallet will list a set of inputs which will refer to the earlier transaction, because if you recall, I said that when I want to pay, I must prove first that I received it from somebody else. So the input will include what I received, from where did I receive the money or the Bitcoins, then output, to whom do I want to pay. So it will have an input which will be previous transaction, output, whom do I want to pay. Once I create this transaction, I'll submit it to the peer-to-peer network. The other nodes will start now processing that transaction to create the block ultimately. So we have created the transaction, we have passed the first stage. The next stage then in the pool, in the peer-to-peer network, is the validation step. In the validation step, we need to ensure that the transaction is valid. Now let me take you back to the check scenario which we were discussing earlier. This step is like the account balance verification step in our normal payment. If I wanted to pay Nishabani by a check, my centralized system will check whether I had adequate balance in my account. But as we said, in Bitcoin, we do not have a centralized ledger. So when I pay Nisha money, somebody must check whether Makarand had adequate Bitcoins to make the payment. So this is the process which I'm calling as one part of the validation step. Now here in the validation step, then you're going to ensure that the transaction has various attributes. It passes various sanity checks. It will have bound checking done, syntax checking done. It will reject the transaction in the validation phase if the transaction is already in the pool. That means if I issued the check initially, you will not use it again. On the same lines, if I use that input once to me once, then that cannot be processed. So this prevents the same transaction from being processed twice. It will also reject this transaction if any of the transaction outputs specified in the inputs have already been spent. So if that means you need to stop double spending. If I already used that check, you can't use it again. So if you find that I'm using a transaction for a transaction input which I have already paid to somebody else, the same cannot be used again by me. So two validations I have spoken to about. One, whether similar transaction is already there in the pool. 2. Whether the transaction which is used by me as the input, has that been used earlier elsewhere? If yes, then that is rejected. It also ensures that what I want to pay Nisha money is equal to or less than what I have received from the others. So in other words, I want to pay Nisha money 10 bitcoins, then my balance must be 10 bitcoins or more. That is the validation it will check. It's possible for me to pay less than what I have received. So if I pay Nisha money 8 but send a message with 9, then that one extra will amount to the fee which I want to pay to somebody. So a transaction value which I am sending out should be less or equal to what I have received in the past. This is the first step of validation in the step number 2, which you see processing in the pool. Now once this step of validation is completed, we go to the script execution step. Now I'll again compare this with our check payment mechanism. This is like the authentication step in normal payments. If I issue a check, some banker is going to verify whether the signature on the check belongs to Makaran, and he will validate that signature. He will authenticate that transaction. Or another example is I'm doing a transaction using my EMV card. I need to enter the PIN. Somebody will verify the PIN. So in this way, in the script execution process, you will verify the digital signatures. I will have my digital signature used to process that transaction, my private key. I will also have the public key of Nisha money used in there. So you will verify whether the sender's private key used to sign that transaction is approved or cleared by using the public key of the sender, that is Makaran, and you will also check whether it is the recipient's address, which is the destination, is also the right one. This is the process of verification, or this is the process of script execution. So basically, the script's job is to make sure that the hash of the public key of the destination address, that is, if I am sending the payment to Nisha money, the hash of my key is the same as the recipient, because in the earlier transaction I was the recipient. To repeat, I would have received a transaction from some party earlier who would have used my public key to send that transaction to me. So in that scenario, the incoming transaction which I received should have the hash of my public key. That should be matched in this script execution step. So in this way, we will carry out the validation of the signatures and ensure that I am authorized to sign that message and I have received that earlier message whose hash I am using in this chain. Now the next step after this is to create the block. So we have completed 2 steps. We have completed the validation, we have calculated the hash. Now we go to the next step, which is the creation of the block. The creation of block step is like sending the check to the clearinghouse. Now we have done the validation, we are sending the clearinghouse in case of a check-based payment. But in the centralized system, we send it only to one single clearinghouse. Here we are now sending this validated and scripted transaction to the peer-to-peer network. Now when I send this transaction after the verification, it will get relayed to other nodes in the peer-to-peer network. The other nodes will now repeat the process of verification which I have done or which somebody has done and relay the transaction to more and more nodes. So each one will carry out the same process which has been done by me in the past in respect of this transaction. And within seconds, the transaction will reach almost all the nodes in the network. The transactions are then held in this pool, this black circle which you see on the screen, which is a public record of all the transactions. And we saw earlier there are many transactions which are flowing. Let me go back to that screen where we saw many transactions which were flowing. Oh, sorry, I've come to the wrong screen. We saw various transactions which are flowing on the screen. Here we are talking about the latest. So now these are verified transactions which are now in the pool. Now once these transactions are there in the pool, the parties, the miners would pick up these transactions. Now and then after picking up these transactions, they will start creating a block of these pools. Let's understand what the concept of block is by visiting that slide a little back, right? So let's take this example now. Now in this example, the picture which you see are same transactions. So this first circle has moved to the second circle also is the same thing. That means transaction A is only moving. I am showing phases of transaction A. This is first part, this is second part, this will be third part. So in this way the transaction will be moving forward from one party to the other party. I'll summarize what we spoke about. Now, by taking this example, we'll understand the virtual coin, the circle which you see here, is the same one, but it is in different points of time, that is at different stages. Now you can see I have the private key P0 or the first transaction and P1 public key. So when I create the first transaction, I was taking my name and Nishamani's name. In this example, I am P0, Nishamani is P1. So when I create a transaction for payment to Nishamani, I will have my private key and Nishamani's public key. Using these keys, I will create a hash of the transactions, including all the previous transactions, and forward that to Nishamani. Now this transaction which I created and forwarded will carry the entire history of the transaction that particular transaction has earlier undergone, and then this becomes a part of the code. Then once the transaction is sent to the next one, to the network, they will examine all the transactions, and when Nishamani receives it, Nishamani wants to pay Rahul, Nishamani will use her private key and Rahul's public key to forward that transactions. In this way, the transaction would flow further. So I am still on the verification and validation process. Now the miners will validate the transactions, and fast computers will be able to do it very fast, and mining will then forward those transactions to the next step. So what is ultimately going to happen in this mining? So we collect the transactions which are now in the pool. Each of the miners will decide out of this pool what transactions should he pick up. He cannot pick up all the transactions. There is a limit on the size of the transactions which you can pick up. At one go, the number of transactions which you pick up, the size of the transaction which you pick up cannot exceed the maximum block size limit. What is the block size limit? The block size limit is 1 megabyte per block. So you cannot cross that. So how will you pick up the transactions from the pool? The transactions which give you some fees. I take that example once again. I want to pay 10 bitcoins to Nishamani, but I broadcast a message of 11 bitcoins that one extra bitcoin is going to be the fee which somebody is going to get. So you will pick up from the pool a transaction which has got more fees, and you pick up those transactions. The maximum transactions which you can pick up can be up to 1 megabit block size. Once you have picked up the transaction from the pool, the next step is carry out the verification stage, which we discussed a little while ago. Verify the signatures, verify the contents. Does the party have adequate money to pay or not? Then once that is done, once you create that, pick up the transaction, select the most recent block in the longest path. Now we said we need to choose the most recent block and the longest path, because if you choose a shortest path, the transaction will get rejected and will come back again in the pool. So the longest chain becomes the blockchain, therefore you need to pick up the longest path. Then once you select the most recent block on the longest path in the blockchain, try to insert the hash of the block header which you have created into the new block. So choose the most recent block, insert the hash of that block's header into the block which you have created newly. I'll take that one example which I took earlier once again. You're attaching various bogies to an engine of a train. You need to ensure that the coupling falls properly in place. That's how your inserting of hash header of the older block into the new block happens. Then you try to solve the proof of work. That means mine that block completely. Now when you find that solution, the new block is then added. That is, your bogie gets added to the earlier bogie. And if somebody else solve that problem first, their bogie will get attached. Their block will get attached first. And this is how the blocks get attached. And once the blocks are attached, the block is said to be mined. And then what we saw earlier was that mined block. Now every miner will try to create the block continuously. Once the block is mined and the block is released, in that case the transaction is completely processed. Now when the transaction is completely processed, then the beneficiary is accepted to have been paid. This is how the Bitcoin transaction processes the transaction. Now we have understood the basic concept of transaction processing, the Bitcoin miners pool, the peer-to-peer network processing, the concept of mining, the concept of hashes. The miners complete the match of blockers head with the unknowns, which we spoke about a little while ago. Then once the hash is accepted at step number 5 by the Bitcoin network, the miner is rewarded with Bitcoins, currently at 25, but it will gradually increase. And as we say at step number 6, the hash values are then added to the next block header, creating the blockchain. And in this way, you end up paying the next party. Now this is the current market scenario. I have completed discussing the process. This is the current market price. Now you can see current market price here on the screen. The market price keeps on changing, going up and down. This is from 2009, but you can see recently only from Jan 17 it has started rising, and within a year's time it has jumped a lot. In Jan 17, in March, let's come down to Jan. In Jan it was $995 per Bitcoin. It went to the highest of $16,000 per Bitcoin in a year's time, Jan to Jan 18, and now it's a little down to $14,000 per Bitcoin. So this is the price movement in the Bitcoin. Let's move forward and look at how do you trade them. Now once you have got the Bitcoin, you want to buy them, exchange them, sell them, get them. So one way to get the Bitcoins is, of course, do the mining and get the miner's reward. The second way to get the Bitcoins, in addition to mining fees, you'll get the fees for transactions. Alternatively, you could buy and sell Bitcoins by exchanging them on various exchanges. This is a list of exchanges which I'm going to show to you where you could carry out your transaction trading. This is a list. It's an international, there are a couple of them are international players. Then you have some players in Europe, Argentina, Australia, Brazil, Cambodia. So you'll have various parties, various countries at which these exchanges are there. And if you want to trade, that is buy and sell, you could visit any of these exchanges, get registered there. Once you get registered there, you can download a wallet, and then based on that your transaction processing can be completed. This is the exchange mechanism of Bitcoins. In addition, now United States, the Chicago Mercantile Exchange, the CME, has also accepted Bitcoin as a commodity, and it has come out with Bitcoin futures. So if you want to protect yourself in respect of future risks, whether the price may fall, if you are holding them, and if you want to buy them, whether the price will rise, you want to protect yourself, you also have derivative products available for doing the transactions in Bitcoins. Now Bitcoins are not pegged to any real world currency, really speaking. The exchange rate gets determined by the supply and demand in the market. There are several exchanges, as we saw, who will enable you to then look at that demand and supply, and based on that demand and supply, your transaction processing, your valuation of Bitcoins will be happening. Now let's come to the last part of the discussion, that is benefits and drawbacks of Bitcoin or cryptocurrencies. Now the advantages which we have can actually be put into different manner. It has got various areas of usage. It has got speed with which your transactions can be done. Cost can be less. Development of alternate payment system solutions can be done. So let's discuss these one by one. I'm not going in the sequence in which they are put on the screen. Now the first and the most important point for those who want to use Bitcoin is to pay, to make a payment. I'm not looking at Bitcoins now as an investment channel. I'm looking at Bitcoins as the payment channel. So when you're using Bitcoin for payment purposes, then one of the advantages which you have is very low fees. In fact, when you open an account in a bank, then you need to pay account opening fees. In fact, recently in India at least, many banks have started charging minimum balance fees. Now if you hold a Bitcoin, there is no account to be kept with anybody. Your Bitcoin is held on your own laptop, on your own machine, so there is no charge which is required to be paid to anybody for holding that currency. Whereas if you have real money, you need to pay somebody your account maintenance fees. And in many countries, abroad as well, that is in Europe and USA also, you would have the banks charging you fees for maintaining balances with them. So point one, there is no account management or account maintenance fee. Point two, when you move the money, again the transaction fees are very low and they are discretionary, which means if you want to pay, you may pay. If you don't want to pay, you need not pay. In this way, the transaction fees will be decided by you. If you wish to pay, you can pay. If you don't wish to pay, you don't need to pay. Again, you have full control over the transaction fees. That is one. And second advantage is that if transaction fees, if defined by you, can be very, very low. This is second advantage. Third advantage, again on the same lines, when you use a typical banking system to make a payment, there will be foreign exchange charges, converting from one currency to other currency. Because for example, I am in India, I want to make a payment to somebody in USA, I will need to convert my Indian rupees into the US dollars. Whereas when I pay Bitcoin, there is no conversion involved at all. I use Bitcoins to pay somebody in USA, that person also is willing to receive the Bitcoin. The cost of conversion does not exist. And therefore, looking at the account holding fees, the transaction fees, no cost of conversion fees, this could be a very cost efficient system for those who would like to use it, especially when you want to make cross-border payments, even including business to business payments or person to person payment. This is from the payment side. Coming from the receiving side, again, for receiving this money there is no cost. We simply need to download a wallet, and once you download the wallet, the money is in there. There is no payment to be given for anybody for maintaining the wallet on the side. Point number 2, in Bitcoins, usually the transaction flows within a period of 10 minutes, maximum 1 hour. So when you want to make a payment across the globe, if it moves very fast, this will reduce the time involved in transaction processing. Now let's take an example. I am a company, somebody like Amazon, and I want to ship you the goods as fast as possible to you. I need to verify, if you make a payment to me, I need to check first whether your payment has been received by me, and then only I will ship the goods. And if the payment is going to be received by me after a delay, and the verification is going to take still more time, then my shipment will not leave fast. But in Bitcoins, I can ship faster because my verification process gets completed faster. And if I'm a player who is a global player operating on a global scale, it will allow me to sell my products across the globe without any issue of exchange control, without any issue of the currency conversion losses. So this gives the advantages to both those who want to pay, those who want to receive. Another advantage of this, now let's come from the clearing system perspective. Now you have various clearing systems like Indian clearing systems, the European clearing systems, the SEPA clearing system, the American clearing systems. If these clearing systems have to make a development of software, or they want to create a new product, it becomes expensive for them because they have to invest. They have to create that product. But in this scenario of Bitcoin or a cryptocurrency, the users themselves, the community itself, the peer-to-peer network itself will go on creating those newer and newer mechanisms. In that case, the cost of new mechanisms becomes less, and you can have multiple ideas coming simultaneously, because if an organization, a single organization wants to make a change, it will think probably only in one direction. But when a group of people is thinking, that thought process could be crossing barriers, and then numerous kinds of new developments can come into this decentralized system. But when we speak about this kind of advantages, there are disadvantages also. So let's understand the disadvantages. Again, I am not going here in the sequential manner. The basic requirement for all this is to have technology. So technical infrastructure, and the users need to have appropriate knowledge for using this infrastructure. That is a barrier. In many countries, people are not educated, or there are many countries who do not have this basic network also available. In that situation, using cryptocurrencies in those countries is going to become difficult. The second problem which cryptocurrencies have is the lack of transparency. We do not get adequate information. For example, you do not know who is on the other side, who is making the payment, who is receiving the payment, because of the anonymity. It is difficult to understand how each of those wallets or each of those systems like Bitcoin or Ethereum or Ripple operate. There is no transparency involved there. There is no transparency requirement at all. In fact, if you go to a bank, a payment system operated by a bank or a regulator, they'll need to disclose. In fact, if you have heard of something called Basel II, there are disclosure requirements of how are you operating. You must disclose the risk about your own operations. But in such a situation, for a decentralized currency system, virtual currency system, it's not even clear who is responsible to be held, who should be held responsible for any transparency requirements, because it's a peer-to-peer network. There is no real single owner, single responsible party for this. To put it in different terms, in IT companies, you do not have a SPOC, no single point of contact, because this is a complete network. You cannot hold one single party responsible. So this is the risk which you face. Another risk which you face in this case, and that has happened in the past, that some of the cryptocurrencies were mined already, and after mining a substantial amount of those cryptocurrencies, they came into the market. With that, what happens is that if they are already holding a lot of stock of such mined currencies, in that situation, it becomes difficult for those subsequent buyers to get more money out of that. So that's another difficulty which is found. Then these activities are banned in some of the countries. So the legal status of many of the cryptocurrencies is very unclear, and the key players in all this cryptocurrency network, they are neither regulated nor supervised, and therefore the users cannot get the benefit of legal protection. There is no deposit guarantee. For example, you go to a clearing system like CHIPS or something like NPCI in India, they will give you a guarantee, an assurance. There is system of central counterparty, and the central counterparty reduces your counterparty credit risk. That kind of situation does not exist in Bitcoins. Then another problem is about the defaults. Many Bitcoin exchanges have defaulted in the past. One more issue is about the attack. Now, how do we get the approval? The approval is given by 51% and more. So if 51% or more move in the other direction, they start behaving in a negative manner, then you could get the 51% attack and the double spending attack. Important issue, one more very important issue, is the lack of continuity. Now, what would happen if one of the important mainly traded Bitcoins, mainly traded cryptocurrencies suddenly close down? So if these networks suddenly close down, the users will face that there is an abrupt stop in the activities. It will leave them with valueless cryptocurrencies. And these key actors, if they discontinue the activity, may result in, maybe because they become bankrupt, maybe because it is not profitable for them. If they stop these networks, then the entire process will fall through. So these are the major disadvantages of cryptocurrency. And the last one, about which the Financial Action Task Force is also concerned, is the anonymity. Though there is the transaction history, you do not know who the actual person is, and that is because the blockchain identifies users only by their virtual currency system's address, and these are pseudonyms. So it's hardly possible to link the pseudonyms with real persons. They are using these addresses. We do not know who are the real persons behind it. We do not know who is the organization behind it. Some are fraudsters. Those who want to fund the terrorists may take advantage of this. Somebody may launder the money. And what you would have noticed from the price of Bitcoin, which I showed to you, is the high volatility. One of the most serious drawbacks for the users of such cryptocurrencies is their potentially high volatility. And this high volatility can result into gains for somebody. This high volatility can result into losses for somebody. Now just imagine a couple of last month the value was $16,000. Now it has come down to $14,000. Those who bought at $16,000 would have lost almost $2,000 per Bitcoin and the investments would have been reduced to that extent. The last point is irrevocable transactions. When you pay using Bitcoin, there is no process of recalling that money. So these are, in a nutshell, the benefits and the drawbacks of a Bitcoin. Now I have gone over my schedule. So let's look at the problem areas and how in some parts of the world these problems have taken place. And once these problem areas, I'll complete them in a couple of seconds. Once these problem areas are understood, then we will take the questions. Now let me conclude the session by looking at this example. As I said, your Bitcoins are stored on your machine. Now one gentleman stored the Bitcoin on his portable hard drive. A person called Campbell Simpson in Australia had Bitcoins. He had 1400 Bitcoins which he stored on a hard drive, and then he dumped that hard drive at some point of time. He just lost that hard drive, and by losing that hard drive he lost 1400 Bitcoins. Just imagine 1400 multiplied by 40,000, it's a huge value. So these are the issues associated with Bitcoin. Here I conclude my session now. I thank all of you for being with me. Now let's understand whether we have any questions from the participants. So now, do you have any questions for me?
Hello?
I'm unmuting everyone. Give me a second, please.
Yes, Abhay here, sir. Thank you very much.
Yes, Abhay.
Thank you, sir. Thank you for your So, thank you for your time. It was very nice. Just one question, out of curiosity, because what we have established in the session is if it is a centralized system, the machines, the power, the network is extremely huge.
Yes.
But what I have realized, even in a decentralized fashion, just because to maintain the speed and the whole, also the complexity of blockchain mining, the computing power at a certain level needs to be there as a prerequisite for these institutional miners. So I don't know if there had been a study which is calculating the total computing power which is used to manage the Bitcoin network as a whole, holistic, and compare that with a centralized system power and find out really is that a comparison really real?
Let me answer your question. Your question is very, very right. Yes. Recently, in fact, last month only, a study has been conducted. There have been studies going on continuously across the globe. So study has been conducted. Even European central banks, the American Federal Reserve, even the American Congress has conducted studies. And there is a recent study available comparing different Bitcoin systems and again comparing different cryptocurrency systems and also comparing these cryptocurrency systems with the parallel traditional systems. I will share that survey separately with you. There is a survey giving details of most of the areas comparing both the types, centralized as well as decentralized.
Okay, thank you, sir. Thank you. Thank you.
Sir,
That
this
is
is
the only.
Ayappa here. Hello.
Yes?
Ayappa here from
Yes,
Bangalore.
Ayyappa, how are you?
Good, sir.
Yeah.
Sir, from your presentation, I understand that miners get Bitcoin for verifying all the transactions, correct?
Yes. Miners get
So,
two things.
that,
Miners, sorry for interruption, Ayyappa. Miners get
uh,
the reward, and if the
uh,
sender has added fees, the miner would also
uh,
get the fees.
can you repeat it, sir? Miner would also get fees. Acha. But
See,
where does it
let
say
me
the
let
fees
me
in the
repeat that example. If I want to make a
uh,
payment to Nisha Money, I want to pay her
uh,
10 bitcoins, but I release 11
okay.
bitcoins, then that extra 1 bitcoin which I have released will get paid to the miner. That would become the fees to the miner in addition to the reward given to him by the system.
Okay, but okay, this I was not aware. I thought Bitcoin is like a without any transaction. It's a zero cost transaction that takes place.
No, but as I
Okay,
said,
and
let me repeat.
uh,
The fees
uh,
is discretionary. If I want to pay her only 10, then I can release a
uh,
message only with 10. If I want, why
uh,
would I add that fee? Let me explain that to you. You put the
uh,
transactions in a pool. If you want to
uh,
have your transaction getting processed much faster, then you must give
uh,
some attraction to the processors, the miners. So how will you give that attraction to the miners is by adding a little bit of fee to that transaction. So when I add a little bit of fee, then the
uh,
miner gets attracted to that transaction because in addition to the mining reward, he will also get the fees. So when I add the fees, it becomes extra benefit, and because of this extra benefit, the chance that my transaction will get picked up earlier than those who have not provided the fees is higher. Are you getting the point, sir?
yeah, I'm getting it, sir. But who actually, because this is a completely decentralized process. So
Yeah.
when I pay the fees, who actually does this allocation of the fees and the transaction? Is it system randomly does it, or
Hold.
do they have any author?
Understood your question. Now your point is
Uh,
when the fees is paid, who will be paid the fees and how it is allocated. Now the fees would get
uh,
paid to the pool which mines that transaction. Okay. On the screen, are you able
okay,
to see a couple of pools?
correct.
Flush pool, BTC, 58 coin. Now when a transaction
Uh,
gets mined and in that when a block gets mined and in that block there are certain transaction fees. Here you can see transaction fee. Can you see on this? So
Yes,
this
sir,
transaction fee
4.298.
is what would go to that pool in addition to the mining reward, and then that pool will share the mining reward plus this transaction fees with all those miners which are part of that pool.
Okay. This was something that I did not know because I had an idea that Bitcoin they're planning to issue only 25 million or I don't know what is the number,
That's
250 million,
21
right?
million.
That's a 21
Million.
million. So that's how, because the incentives for mining would end up with the 21 million. So
Correct.
later on they will have to depend on the fees, I believe.
Perfect. You're very right in your understanding, sir.
Fine. That was only doubt, sir. But how about like if Bitcoin is so popular, then why do people go for Ripple, Ethereum, and other coins? Like I think Ripple some of the financial institutions are also testing it and they're planning to make it a regulated currency. That's what I read. But apart from this, everyone can only bet on Bitcoin, right? Because it's been more transparent.
I'll ask a different question, Ayyappa. Since you have an investment banking background, let me ask you a question. On the stock exchanges, so many shares are available. Are people going only to a particular company, or they buy different kinds of shares?
No, for example, in India, like, your question should be like, why there are multiple stock exchanges instead of having one stock exchange?
So I'll not put it that way. The reason why I'm arguing in this manner is you could go to a Bitcoin and Ethereum or a Ripple is because people who are buying those see a different value, and if I'm investing in that, I see a different percentage of appreciation in each of them. For example, I may have a view that Bitcoin has already appreciated, so no point in investing further in Bitcoin. Let me go for a Ripple. I would also look at the volatility. I would also look at the volatility in the prices of those applications, of those prices. So if you look at the prices, look at the volatility which is available here. You can see the percentage changes in the price. Are you able to see the screen?
Yes, I'm able to see that. Like,
So you can see the percentage change in the price. This is what I would call as volatility. So some people who are risk averse may not want to go for a currency which is highly volatile, and may want to go for a currency. For example, Bitcoin Cash is less volatile as compared with Bitcoin. So it again depends upon the risk appetite of each of those parties who are intending to buy or sell this currency. Am I making sense?
Yes, I got that point. But what I'm looking at, the bigger picture is, going forward, all the businesses will start accepting Bitcoin as a currency. Like Ferrari or some automobile companies have already started. So
Yes.
do they have the same kind of an attitude for Ripple, Litecoin or other coins that you pay in Litecoin and buy a Ferrari or a Microsoft product?
Frankly speaking, Ayyappa, everybody is watching from outside the pool. They are still testing the waters.
Okay. Fine. And sir, this Bitcoin Cash, is it like a stock split, or how does it work, sir? Actually, that was one doubt which I had. Bitcoin and Bitcoin
Cash
Cash.
is only a name. It's the process of all these are identical. There's no difference. These are all cryptocurrencies.
Okay, it's like two different companies. Bitcoin and Bitcoin Cash are
Right.
completely different.
Very right.
Fine, sir. I think I have clarified the doubts. Thank you.
Yeah. Now there is one question from Rahul Juneja on the panel on the screen. That do you foresee blockchain will be a strategic solution going forward with Ripple? Can it replace SWIFT payments in the cross-border? Now, Rahul, are you aware of the GPI, the Global Payment Initiative of SWIFT?
No, sir.
Yeah, in the Global Payment Initiative of SWIFT, which is currently applicable to message types MT103, 103 STP and 103 remit, they have created a global payment initiative where instant payment, I would not say instant payment, but faster payments would be done with more kind of transparency. In that, currently we are in phase 1. In phase 3, plans to use or intends to use, or it is testing using the blockchain process in the cross-border transactions. So going forward, in fact, SWIFT may compete with somebody like Ripple or somebody like a Bitcoin in cross-border payments if the GPI phase 3, which they call as V3, is implemented.
Okay. Okay. And I have one more question. Can I ask?
Sure, go ahead.
Okay, so I'm saying, like, all these cryptocurrencies, they come out with a specific quantity. How they regulate that they are only going to have 100 millions or billions of coins. After that, they will not generate it. So what is the quantum they follow?
There are 2 points, Rahul. One point is you do not allow them to be generated at one go also. That also is another point you need to think. That we will not allow all 21 million Bitcoins to be mined at one go. It has to be mined up to 21 billion in a phased manner. Am I making sense to you? It will not be mined at one go, right? So now, let me explain first how do you control it in the phased manner. You do not allow the blocks to be processed very fast. To do that, you would have noticed there is this concept of difficulty level. So the moment the block mining becomes faster, we will increase the difficulty level in the algorithm. The moment it becomes slower, we'll adjust the difficulty level, and this is how we will maintain the pace at which the blocks are getting mined. This is one part of the answer, where you cannot you cannot mine everything then at one go. It will be mined at a given space, at a given pace. Second point is, in the algorithm, block is built, or instead of saying a block, system is built where once the mining reaches 21 million bitcoins, further mining would not be permitted. That process itself will get halted. That's how it has been implemented in the cryptocurrencies.
Okay.
So
Sir, like my question was like Ripple got created, right? The company created Ripple as a currency, XRP. So
Yeah.
they have quantified that this is the total number of XRP will be circulated around.
Correct.
It cannot be exceed more to that number. So
Okay.
how they have came with that conclusion, and what is the regulations that we know that it will not generate to the number what they have already shared with everyone, that it won't exceed to that a single XRP more to that number?
Okay, I'll start from the back side. The last question I'll answer first. First point, there is no regulation regulating anybody here. So if they do more, there is nobody stopping them. This is point one. Now let's look at one more point which we discussed earlier. Let's go back to that advantageous scenario on the screen. Now if you look at the advantageous scenario, one of the benefits which you are saying is there in this cryptocurrency is an inflation hedge. This is one of the important points which is their marketing USP. Now let's take a normal fiat currency. You have a fiat currency like the US dollar, the euro, the Australian dollar, or the Indian rupee. Now the central banks of these countries have the right, in fact, to print as many numbers of currency notes as required. There is no restriction on a central bank saying that you cannot print above a certain number of currencies. With this, what happens is that today, if a country has printed, let's say 100 currency notes, and tomorrow it prints another 100 and has total 200, then the value of that currency note goes on falling. And this is what, then the prices start increasing. This is what we call as inflation. Are you in sync with me up to this point, Rahul?
Absolutely, sir. Yes.
Okay. So therefore, then people who are investing in those fiat currencies do not see much benefit, because the real return which they get has to be adjusted for such inflation. In case of cryptocurrencies, you will not allow them to use a different word, print or create more than a certain number. Then since more numbers cannot be created, the value automatically will get controlled, and at a later point of time, when you reach the maximum, the demand only will continue, but supply will remain stagnant, the price will increase, and that's how people will make money. So it is in their benefit to control the numbers so that supply remains less, and if supply is less, then only the interest in that currency will continue. That is the logic with which they have put this block. Are we clear, Rahul?
Yes, absolutely, sir. Thank you.
so this is Chandrasekhar from Bangalore.
Yes, welcome, Chandrasekhar.
Thank you, sir. I have a couple of questions. One is with respect to India has made a statement. Indian foreign minister has made finance minister has made a statement that coins are not going to be, the cryptocurrencies are not going to be accepted. Whereas at the same time, Geo is making a Geo currency or Geo coin. How actually this is going to work, and what's your thought on this?
Okay, 2 points. First point is that the government is not saying yes, not saying no. They keep saying sometimes that people who are investing in cryptocurrencies need to be careful. The Reserve Bank of India also keeps on saying this, but they are not saying anywhere specifically that we are banning cryptocurrencies. So we are sometimes blowing hot, sometimes blowing cold. This is point one. Point two is about Geo as a cryptocurrency. In fact, we have permitted in the past also the currencies in digital form. Now let me ask you a different question. Do you use something like Ola Money or a Facebook Cash? These are all digital currencies only. When you pay Ola or when you pay Paytm, what you move is Paytm money or Ola Money. You agree with me? That's also in the
Yeah.
same form. So Geo is also going to be identical. But all these Geos, Olas, or your Facebook are centralized. So if you control a Geo, you control an Ola, then it becomes easier for those authorities to monitor them. That advantage is not available in case of cryptocurrencies like Bitcoin. So are you seeing the difference between Geo Money, Ola Money, or even I took Paytm as an example earlier? These are all centralized systems. They are not decentralized systems like what Bitcoin or the Ripple want to do. Am I making sense to you?
Okay. Yes, yes, yes. Actually, that was the thing, and you made it very clear. Yes, they will be the centralized currencies. Yeah, it's not a
They are
decentralized.
easier to control,
So,
therefore the regulators are fine with it.
okay, okay. So I have one more question with respect to loyalty points were there since a long time with respect to the credit card introduction and other things. Can we consider the loyalty points as the backbone of this kind of a cryptocurrencies coming up now, or should we only go with respect to the blockchain as the technology?
No, loyalty points are, see, to keep the miners engaged, you need to have some kind of a reward for them. And as I was discussing with Ayyappa, the rewards are going to dry up once you reach the maximum level. Therefore, some kind of incentive is necessary. So royalty points need to be considered, really speaking, to keep the chain alive. Otherwise, what will happen? Without any loyalty, why should I be doing the mining if I have no benefits?
Yeah, yeah. So one last thing, it's not about the presentation, but beyond that, will MVL Co start this particular course and offer to the people as a full-fledged course, and if so, when it will be?
We are going to offer it. When is something which I am unable to answer at this point of time because it's pending with our internal team which is processing or creating that content nowadays. So we are going to do this, but when is an answer? I will ask somebody to get in touch with you so that they can tell you when this is completely ready.
Yeah, that will be very useful, sir, because this is something where actually people cannot get the information, and actually your examples, especially I'm really gone crazy with your Rummy example. It is so difficult to understand miners and what they do at the time of mining, and Rummy example is a fantastic one. It will be great if you can please offer this kind of a course to the public.
We'll definitely look at that. Thanks for your encouraging words.
Thank you, sir.
Hi, Manan, this is Adarsh.
Hello.
Hi, this is Adarsh.
Yes, Adarsh, how are you?
I'm good, thank you. How are you?
Nice to connect after a long time.
Yes. A quick question on blockchain. I'm reading about it and seeing a lot of banks adopting it. Recently, SBI and other US banks are also adopting. Now, my question is, using blockchain for ledgering purposes, will it impact any audit or reporting requirements?
Yes, blockchain for ledgering purposes, it will impact the reporting. I believe you are speaking, Adarsh, about regulatory reporting.
Yes.
Yeah, it will impact the regulatory reporting requirements because today, let's look at two regulations. One kind of regulation is I'm sure you understand what I mean by systemic risk in a payment system.
Yes.
Now, when you want to monitor the systemic risk in the payment system, you are controlling the kind of parties who become a member of your payment system. Now, with this kind of a concept of blockchain, it will become quite difficult to control who becomes the member of your payment chain. And then preventing systemic risk, or at least measuring and monitoring systemic risk, has to be done effectively by the payment system regulators, and for that they need to get the reporting about who are the parties, who are the processors in the blockchain kind of a payment system. This is point one. Second point is compliance with something like your FATF requirements. Again, you have got regulatory reporting, you need to file your CTRs and STRs. Now, point one, in such a system, who will be responsible first to file the CTR or the STR? You will need to have clarity on that. How will you generate your CTR and STR is another issue we'll need to address. So I'm just telling you about 2 or 3 kinds of regulations, but having look at the different kinds of regulations then in place, would have to have a different kind of reporting systems and kind of different reporting formats for doing the regulatory reporting in respect of such transactions.
All right, and these are yet to be framed or yet to be become operational for the banks.
I'll tell you why. Your point is right. They have not yet become operational because many countries are not yet able to decide whether they should treat the cryptocurrency as a commodity or as currency. So if you do not know what that fruit which you are trying to eat is, how will you then decide the regulation about that?
I agree, but on the other side, any kind of cryptocurrency is more kind of hype, not based on assets, which means it's more kind of a lottery,
Right?
Or gambling.
Yes.
So, any transactions done with such kind of platforms, wouldn't that be considered as gambling?
That is not considered. Let me give you the view which the Indian Income Tax Department has taken recently. They have told the parties, the department has told its officers that cryptocurrencies like Bitcoin should be treated as an asset. We do not treat them as currency, and if you make a gain in that, if you continuously trade in that, it should be treated as business. If you trade once in a while in that, it should be treated as capital gain. On the other hand, the GST authorities are saying that we will treat this as a service and we will charge you. So the governments are definitely looking at this point, and they are not treating it as gambling. I think probably some of them are looking at it as the government should also be making money out of that. That's the way I believe currently people are looking at it.
All right. Yeah, thank you.
Yeah. So,
Dunka, I have a small question.
yes, Nisha.
So, yes, so far so clear, but I have a small question. How a newcomer for the Bitcoin will get the initial Bitcoin base, that how he will be earning it? Is it from a transaction only, or is there any other way to earn Bitcoins?
Yeah. Now,
For a newcomer.
One way to get a Bitcoin, Nisha Money, is to buy it through the exchange. I showed you a couple of exchanges, and I'm sure in Sri Lanka also there could be a couple of exchanges where a Bitcoin could be purchased. The second way is you exchange you get a Bitcoin by providing services or selling goods. So for example, I sell a car and tell the buyer to pay me by way of Bitcoins. That's another way. Or I provide some services, maybe a training service, and tell the guys to pay me through Bitcoin. So I could earn a Bitcoin by doing some activity like training. I could get a Bitcoin by selling something like a car. I could buy a Bitcoin. This is two. The another way, of course, we understand is by doing the mining activity. If we do the mining, I will be able to get the Bitcoin. So to summarize, three ways: mine a Bitcoin, or two, sell goods and services, three, buy it on an exchange, are the ways of getting a Bitcoin.
Okay. Okay, Lanka, that's clear. Yes.
Hi Makarand, this is Ashish.
Yes, Ashish.
Makarand, my question is very generic. Just wanted to check, like, what will be the blockchain future in banking?
Blockchain is...
You talked about...
Yeah, sorry, please continue.
Sorry, you talked about payments, like GPI you talked about, which will be a future version of SWIFT right now. Then you mentioned about trade finance is also one of the future areas. But anything else where you can foresee that blockchain will have major impact on the banking industry?
Trade finance, banking, even your security settlements, they will definitely be looking at the blockchain. So as you're saying, Ashish, these entities are going forward and doing research in many places, including, let's take one more example. Now, even my book transfers in a bank could be done by using a blockchain if I create a group of all these people in my bank. And the banks will definitely be required to have the clear understanding of blockchain, part one. Point two is they need to understand and implement it effectively so that they can reduce the cost, and they will have to improve the delivery to the customers. So I'm not saying that blockchain per se, I will not discuss the same thing about the cryptocurrencies, like Ashish said that they are still maybe some kind of a bubble, but blockchain as a technology will definitely grow in future in the banking industry. That's my personal view.
Okay. So Makran, can you see these digital payments that are coming in future will use blockchain as a base for future payments?
Let me tell you one point. The tussle will be between the centralized systems and the decentralized system. Now you will see that across the world, centralized systems are deeply entrenched in the payment sector. They would definitely fight back when something like a decentralized system tries to eat into their pie or in their piece of cake. So one resistance which is going to come is not from the perspective of technology or not from the perspective of who is going to use them, is going to come from those who are well entrenched in this system. So unless they change that stance, that regulated, the decentralized also has to work in tandem with decentralized, you will face that difficulty first. So that is problem number one which you will face. The second problem is it's only related to cryptocurrency. I don't see that problem in case of the other usages like using it in a trade finance or using it in maybe your security settlement. So in cryptocurrencies, currency payments will get affected. But apart from that, I'll repeat what I said, blockchain is going to grow in other parts.
Okay, thank you so much, Makran.
Hi, Makran, Nikhil here. How are you?
I'm fine. How are you doing?
I'm doing good, thank you. Makran, I have a quick question. So I've heard that anyone can create their own cryptocurrency.
Yes.
So my idea is if I have to create my own cryptocurrency, and since it is a decentralized system with no norms, do I need to follow any regulations, as in do I need to register an organization or something in order to do so?
No, there is no such regulation. Let me tell you one thing, Nikhil. Currently,
Yeah.
there is nobody regulating the cryptocurrencies. That can be seen as an advantage. That can also be seen as a disadvantage. The advantage is from this side, this point, that when you want to create, pay, receive, nobody can ask you a question. The disadvantage is from this side, that if nobody is controlling it, if something goes wrong, there is nobody who will hear out your case.
Okay, I get that. So in case of creating a cryptocurrency of my own, like, is there a way to do it, as in from where can I go ahead with it or get more information about doing it?
Let me tell you one more point first. Before anybody creates any currency, any currency becomes successful only on the basis of acceptability. So you should first
Okay.
look at the manner in which you can make it acceptable. Let me give you an example from India. Now, last year,
Sure.
in 2016, the government of India had currency notes of 1,000 rupees and 500 rupees. Before a certain date in November, we are accepting them very, very happily. But after that date, suddenly, just because the government said they are not acceptable, they lost their value. So the money has value only if it is acceptable. Money has to have certain basic features. So when you want to create a cryptocurrency, you need to understand whether you will be able to provide those basic features. What are those basic features required in a money? The basic features required in the money that it should be acceptable as a medium of exchange. If you are going to pay me in your currency called nickel currency, people should be willing to accept that nickel currency. So it should be usable as a medium of exchange. Second, why it becomes important, why rupee or a dollar is accepted also otherwise, is because people use it for accounting. So when I tell you that I have my property, I will say my property is worth so many Indian rupees or so many US dollars. So it is used as a unit of account, as a unit of measurement for value and cost of goods, services and assets. And it is also used as a store of value. I can say I'm having $50,000 in my pocket. That's the value which I'm carrying. So when you create a currency, in addition to acceptability, you should look at whether people will take it as medium of exchange, unit of account and store of value. And there is a book, manual on compendium of creation of cryptocurrencies. It's available on the internet. You can buy that book and it will tell you what is the process to be followed.
Okay. Thank you very much for that, Makran. And I have one more question. Sorry for that. So you explained the concept of data mining. So is it like data mining can be done by anyone and everyone, or then again are there certain rules and norms to be followed, and how does like any common man or anyone who is interested in doing data mining go about it?
Okay, the same point again is currently there is nobody regulating what should be done, who should do mining, who should create currencies. No regulation at all exists. Now to do that, the only thing you need to do is download an application. These are open source applications available on the net. Download it the way I showed you, the GUI miner, and you could start mining.
Yes.
The problem will come when you start earning, then you may have tax authorities asking you a question. You may have your GST authorities asking you a question that you are providing a service of mining. What is the GST you have collected? You have made profit in the service of mining. Are you paying your income tax? These are the kind of questions you should read. So currently, to start the activity, there is nobody asking a question. But the moment you make a profit or a loss out of this activity, there will be people who would want to have a cake, a piece of that cake.
Awesome, awesome. Thank you very much, Makran.
Good. So now at this point, I would thank all of you for participating in the session. It was very, very nice to have all those questions. And thanks a lot again for giving me this opportunity to make a presentation to all of you. Thanks a lot and have a nice remaining day.
Thank you very much, Makran. Have a good time.
Thank you.
Thank you.